Welcome to this Unit 2 practice paper. We're going to do the November 2014 Unit 2 paper, and I'm doing this so that you can see how to answer questions correctly in an exam to get every mark possible. Please don't forget, as with all things in mathematics, there are a number of ways of doing the same thing. So if I do something in this demonstration that you're not familiar with but you have your own techniques, please use those. You will still get the marks. First thing to notice on the exam paper, on the front, it gives you 1 hour and 15 minutes to do the Unit 2 paper. There's some instructions that you need to start getting a grip with from this early stage of the course. You need to use black ink, and draw diagrams in pencil, and there's a very good reason for that. If you get a diagram wrong, you need to rub it out. You don't want to make it look untidy, especially with graphs. Fill in the boxes at the top of the page, so on your big day you'll do your name and your candidate's number. You'll be given that on the day. And answer all questions. The all is in block capitals and bold because it's really important that you attempt every question. If you don't attempt a question, you can't get the marks. You must answer all questions in the space provided. Please don't go outside the box. That's where the examiner puts his marks and his notes. And do all rough working out in this book. If you need some scrap paper on the day, it will be given to you, but anything on the scrap paper won't go towards your marks. The marks for questions are shown in brackets, so please take note of them. The maximum mark for this paper is 66. It's always 66 on Unit 2 papers. Some questions will require you to write answers down, and you will be marked specifically on your written communications. In other words, your spelling and your grammar. In this paper, it's telling you that questions 3, 14 and 15 will require you to write things down as meaningful sentences. These questions will have an asterisk, so you know you should be writing something down for these in plain English. You can ask for paper and graph paper if required. And then finally, the advice at the bottom: in all calculations, show clearly how you work out your answer. So saying, for example, 108 divided by 6 equals 18, if you don't show them the long division on how to get that, you won't get the mark. Okay, question 1 always tends to be a nice straightforward question to calm your nerves down and get you thinking about mathematics in the most basic ways, and it's usually to do with place values or basic numbers. So the first question, 1a, write down the value of the digit 5 in the number 5348. You can put this down in a number of ways. You can write down the number 5,000, or you can write the word down thousands. Both answers will give you 4 marks. Write down the number 5348 to the nearest hundred. So the hundreds are the 3, so to the nearest 3 is 5,300, because the next digit along is the number 4, so we round down. So with rounding, you're looking at 3 because we're interested in the hundreds, and you base your decision on the next number along, which is a 4. So it becomes 5300 because we round down. What is the largest number you can make using all 4 cards? Straightforward again, you're just rearranging them to give you the biggest place values possible with the digits 5, 3, 4 and 8. So the biggest number you can get is 8, 5, 4, 3. 8,543, the biggest number on the left. And then finally, what is the smallest odd number you can make with all 4 cards? So they need you to finish off with an odd number at the end. So that's either 3 or 5. Well, to get the smallest odd number, you would put the 5 to the extreme right so that you can put the 3 further up the number. So the smallest odd number you can get using the cards is 3, 4, 8, 5. The next question is about multiples and factors, and also square numbers. Again, straightforward. It's asking us to circle the multiple of 7. So multiples means your times tables: 7, 14, 21, 28, 35. So the number that is a multiple of 7 is 35. Question B. Circle the factor of 36. So factors are numbers that go into other numbers. So again, you can do it by your times tables of the numbers they've given you. So 8, 16, 24, 32, 40. So 8 isn't a factor. 12, 24, 36. So 12 goes into 36. And then 2C. Circle a number that is not a square number. So the square number is the result of a number that has been multiplied by itself. So you need to recognize these straight away. So 8 times 8 is 64, so 64 is a square number. 6 times 6 is 36, so 36 is a square number. 11 times 11 is 121, so 121 is a square number. So the number that is not a square number is 48. Question 3a. Work out the cost of 4 bottles of milk that cost 65p each. So here they're testing you with your times tables and your method for multiplying. So if I use the column method, I have 65 and I'm going to multiply it by 4. So 4 5s are 20, 2, 0, and 6 4s are 24, plus the 2 I've already got is 26. Now this is 260 pence. They want the answer in pounds. So don't forget to move your decimal point 2 places to give you £2.60. Again, don't forget to check your answers to make sure your answer makes sense. Finally, 3b. Molly pays for 4 bottles of milk with a £5 note. How much change should she get? 1 mark. So here you have £5 and you're going to take away £2.60. You don't really have to show the method for 1 mark, you just need the correct answer. So if I show you the correct subtraction method, it's £2.40. So £2.40. Question 4 is all about swapping between percentages, fractions and decimals. So write 30% as a fraction. So 30% is 30 over 100. So we know with fractions we can simplify. So if we cancel each of the zeros off, it becomes 3 over 10. So the answer goes on the answer line, 3 over 10. Write 80% as a decimal. Well, we know 80% is 80 over 100. And when we write a decimal, we have our decimal point where the first column is our tens and our next column is our hundreds. So really we don't need to show this 0 here because it doesn't mean anything in decimals. So our decimal for 80% is 0.8. Question 4c. Circle the 2 values that are equivalent to 2/3. So 2/3, by recognition, it's one of those fractions you need to recognise, is 0.6666 recurring. So the first one that represents 2/3 is 0.6 recurring. The second value is not so easy to spot. 66 divided by 100 will give you 0.66, so it doesn't recur. 60 over 100, if we simplify it, gives us 6 over 10, which is 0.6. Again, it's not the same as 0.6 recurring. We know 0.6 isn't 2/3, so that must leave 66 over 99. If you want to know the maths behind it, 66 over 99, when we simplify it, by dividing both sides, let's say by 3, gives us 22 over 33. And when we divide the top and the bottom by 11, we get 2 over 3. So it is the same of the fraction we're looking for. Question 5. 3 bags can each contain the same number of discs. 2 discs are taken out of one of the bags. There are now 5 discs in the bag. Work out the total number of discs that are now in the 3 bags. So, if we look at our original bag, there are now 5 discs in the bag, and we add the 2 that were taken out, it tells us that the bag originally had 7 discs. If each of the 3 bags contain the same number of discs at the start, then each bag contains 7 discs, so we multiply 7 by 3 to get 21 discs that we started with. However, it's saying work out the total number of discs that are now in the bag, or in the 3 bags. So we had 21, we need to take away our 2 again, which leaves 19. So the number of discs that are now in the bags is 19. Question 6. A sequence begins 1, 6, 16. The rule for the sequence is double the previous term and add 4. Work out the next 2 terms in the sequence. So, our problem says double the previous term and add 4. So we need to start with 16 and double it, so multiply it by 2 to get 32. And then add 4 gives us 36. So our next term in our sequence would be 36. To find the term after that, we're starting with 36 and we're multiplying it by 2 to get 72. 72 plus 4 equals 76. So the next 2 terms in the sequence are 36 and 76. Question 7. Asif has 10 coins. He has only 10 pence, 20 pence and 50 pence coins. The 10 coins total £3.20. Work out how many of each coin he has. So here this is kind of a trial and improvement question, but it also requires a bit of common sense. We only have 10 coins to play with to make up our £3.20. So I would concentrate on the 50 pence coins to start with and say, for example, a good number to go for would be 4 50 pence coins. So if I have 4 50 pence coins, it gives me £2. That means I need another £1.20. Well, with 10 and 20 pence pieces only to play with, it means I'd only have 6 20 pence coins to make up the difference, which would give me my £1.20 I'm looking for. However, in this situation, I don't have any tens, and Asif has 10p coins. So all I would do then, with trial and improvement, was up the number of 50p coins I have. So I'd then try 5 50p coins, and this would give me £2.50. This means I need another 70p from my remaining 5 coins that are 10s and 20s. Well, I can do this. If I have two 20p pieces, it gives me 40p. And if I have the remaining 3 coins at 10p, it gives me 30p, which means my total would be the £3.20 that I'm looking for. So my answer is 3 10p coins, 2 20p coins, and 5 50p coins. Question 8. Algebra questions. Part A. Simplify 2f plus 3e plus 4f. We can only add like terms, so the like terms are the f terms. 2f and plus 4f. So 2f plus 4f is 6f, and then I have a plus 3e that I can't do anything with. So the answer is 6f plus 3e. The next question is asking me to solve a one-step equation, x minus 7 equals 29. I could put the answer straight down using common sense, or I can show the examiner that I know what I'm doing with one-step equations. So to get rid of the minus 7, I add 7 on both sides. This leaves me with x on its own on the left and 36 as my answer on the right. Question 9. A recipe needs 300 grams of flour to make 4 cakes. How much flour is needed to make 6 cakes? And this has 2 marks. There are 2 ways to do this. You can say, how do I get from 4 to 6? Well, I need to multiply it by 1.5. 1.5 times 4 is 6. If I do that to the number of cakes I'm making, I can do that to the amount of flour I use. So if I multiply 1.5 by 300 grams of cake, I know 1 times 300 is 300, and half of 300 is 150. So I know it's 450 grams. My answer on the answer line would be 450 grams. There is another way where you can work out what 1 cake is worth. So if I have 300 grams and I divide it by 4, it tells me that 1 cake is 75 grams. If you want to show the examiner the long division, 4 into 300. 4 doesn't go into 3, carry the 3. 4 goes into 30 7 times, 7, 14, 21, 28, remainder 2. 4 goes into 20 5 times. So when we divide 300 by 4, it tells us 1 cake is 75 grams. I then need to multiply my 75 grams by 6. So again, if you want to, you can show the examiner 75 multiplied by 6. 6 5s are 30, 3 with the 0 going down. 6 7s are 42, plus the 3 is 45. So again, we still end up with our 450 grams, but in a slightly different way. Part B of the question says, the recipe needs 300 grams of flour for 4 cakes still, and 1 kilogram is 1,000 grams. How many cakes can be made from a 1.5 kilogram bag of flour? So here we're looking at a ratio. So we have a ratio of weight to the number of cakes. So for every 300 grams, I have 4 cakes. It's giving me the weight in kilograms. So I have 1.5 kilograms that I need to multiply by 1,000. So to do this, move your decimal place 3 places. 1, 2, 3. So we need to put zeros in here, and it gives us 1500 grams. So we've gone from 300 grams to 1500 grams. So to work out the number that you're multiplying your ratio by, you divide 1500 by 300. Again, simplifying it, we can divide both sides by 10 and by 10 again, and it gives us 15 divided by 3, which you hopefully all get, because the top and the bottom can be divided by 3, gives us 5. So we've multiplied 300 by 5 to get 1500. So all we need to do on our cake side of our ratio is multiply it by the same amount. So 4 times 5 is 20. So the number of cakes that can be made with 1.5 kilogram bag of flour is 20 cakes. Question 10. Students are put into 9 groups. 5 groups have 24 students. The other 4 groups have an equal number of students. Altogether, there are 204 students. How many students are there in each of the other 4 groups? So we know there are 5 groups with 24 students. So 24 times 5, 2 carry the 0, 5 2s are 10, plus 2 is 12. So the 5 groups of 24 accounts for 120 students. So we have 204 students to start with, and we know the 5 groups have 120, leaving 84 students. So we're left with 84 students, and we're told that there are 84 students and they're divided into 4 equal groups. So 4 goes into 8 twice, 4 goes into 4 once. So there are 21 students in each of the other 4 groups, and that goes on the answer line. Question 11a. Write down the value of 10 cubed. This is one of those numbers we need to recognize. It's a 1-mark answer, so 10 times 10 is 100, times 10 again is 1000. So 10 cubed means 10 times 10 times 10. So you're quite literally putting a 0 for each one. So 1000 is the answer. 11b. Work out the value of 0.4 times 0.2. And I have warned you in the classroom that you will get one of these questions. The way to do this is remove the decimal points and do the basic maths, and then put the decimal point back. So here we have to move the decimal point 1 place to make 0.4 4. And here we have to multiply 0.2 by 10, in other words move the decimal place 1 place. So we have a total of 2 places we've moved our decimal points, and that gives us 4 times 2, which is 8. Now this is a bit a lot of people get wrong. The decimal point is here with 8, so we need to move it 2 spaces to the left to account for the 2 that we wrote over here. So our answer is 0.08. Complete the table of values for y equals 3x plus 2. So substitution. 3x means 3 times whatever my value of x is, and then add 2. So in the first instance, I'm swapping x for the number minus 2. So it becomes 3 times minus 2 plus 2. Now BidMath says that we have to do the multiplication first, so we do 3 times minus 2 first, which gives me minus 6, a positive times a negative, gives me a negative, and then we're at minus 6 and we need to add 2. So now we're testing you on negative numbers. On my number line, I'm starting at minus 6, if this is 0, and I'm going 2 in the positive direction. So I end up at minus 4. So minus 4 goes on my y. For the next one, where x is equal to 0, let's use a different colour pen, it becomes 3 times 0 plus 2. So again, BidMath kicks in. We do the 3 times 0 first, which is 0. Anything times 0 is 0. add the 2, gives me 2 for my y value. And then finally, we need to substitute the value of 2. So it becomes 3 times 2 plus 2. BidMath says 3 times 2 first, so it gives us 6, plus the 2 gives me 8. So the y values are -4, 2 and 8. It then asks me to plot those points that we've just got from the previous slide. So now we plot those points. So the first point was -2, -4. So notice how I use a cross to mark the point on the graph and not a point, because when we draw our line, the points disappear under the line. -1, -1 was the second point. 0, 2 was the third point. 1, 5 was next. And then finally 2, 8. And if you've done your calculations from part A correctly, they should be in a straight line. When it says draw the graph, it means put a straight line through those points. So in the exam, you'd use a pencil to draw through your points and show them the line y equals 3x plus 2. The final part of question 12 is asking you to work out the gradient of the line y equals 3x plus 2. And it's only 1 mark, so you know it's not a difficult question, they just want the answer. I think they've tried to confuse you with this by saying using the words work out. Well, you don't need to work it out. You need to recognize it. And you need to recognize that the number that multiplies x in a straight line equation is your gradient. So the gradient of this line is going to be 3. Question 13. There are 32 packs of crisps in a box. Millie buys 5 boxes for a total of £48. She sells 140 packs at 40p each, then sells the rest at a reduced price. She makes a profit of £13.80. Work out the reduced price of each packet. You must show you're working out, and this is 5 marks, so there's a lot of working out. If you don't get the right answer on the answer line, there's still 4 marks to get some basic working out. So let's pick off each of the marks that are involved with this question. You can't afford not to attempt it. So to start with, Millie buys 5 boxes of crisps. So 32 times 5 tells us how many packets of crisps she's got in her 5 boxes, which is 160 packets of crisps. And these cost her £48. She sells 140 packets at 40p each. So if we take away the 140 that she sells, she has 20 packets left that are going to be at the reduced price. But we need to work out how much she made from 140 packets at 40p. Well, we've talked about multiplying big numbers in the past. You just strip off the zeros, so you end up 14 times 4. So that is 16, 4 fours are 16, 4 times 4 is 4, 4 times 1 is 4, plus the 1 is 5. So 14 times 4 is 56. So we know it's 56, but we took away 2 zeros. So she's made 5,600p, which is £56. Now, we know she bought the crisps for £48, so far her profit is 56 minus 48, which is an £8 profit. What we need to do now is work out how we make the rest of the profit that she makes. So if we have our £13.80 that she made, and we take away our £8, it gives us £5.80 that she needs to make with the remaining 20 packets of crisps. So essentially, this becomes £5.80 divided by the 20 to tell us how much she sells them. So we're left with £5.80 divided by the 20 packets of crisps. The easiest way to do this is make the £5.80 into pence, and then it looks a lot easier. So if we look at it in terms of a fraction, it's £5.80 being divided by 20. Well, we can simplify, we can get rid of the zeros. So it becomes 58 divided by 2. And you can use the long division method if it makes it easier for you. So you have 58, we divide it by 2, 2 goes into 5 twice, remainder 1. 2 goes into 18, 9 times. So it tells us that she charges 29 pence for the reduced packets of crisps. So 29 pence goes on your answer line. Question 14, Part A. This is asking us to factorise x squared plus x. Factorising is the process of putting things inside the brackets. However, before we do that, we need to find what goes outside the brackets, and that is whatever is common to each of our terms. So we have an x squared term and an x term, and the thing that is common is the letter x. We then need to open our brackets and ask ourselves, what do I multiply x by to get x squared, to get our first term? Well, x times x is x squared. Then I've got my addition sign, and I need to ask myself, how do I get my second term? What do I multiply by x to get x? Well, x times 1 is x. So on the answer line, you need to write x brackets x plus 1 to factorise x squared plus x. Part B is asking us to work out the value of x squared plus x when x is minus 3. Well, x squared means x times x. So let's see what happens when we put minus 3 in there. Minus 3 times minus 3, well, it's a minus times a minus, so our sign rule says the answer is going to be positive. So 3 times 3 is positive 9. It's then asking us to add minus 3. So again, it's testing us on the sign rule. So we have a confliction between our positive and negative signs. The outcome of a positive and negative is a negative. So if we rewrite it neatly, 9 minus 3 is 6. Therefore 6 goes on our answer line. Question 14c is all about algebraic argument and testing things by putting values in. So n is an odd number. Tick the correct statement. N squared plus n is always odd or even, or it's either odd or even. So the best way to prove this and tick the correct one is to try squaring a couple of numbers that are odd. So let's select 3. So if 3 is squared, we end up with 9. Plus 3 gives me 12. Let's try another number that's odd. 5 squared is 25, plus 5 is 30. So our answer is always even, but we haven't given the correct reason. So remembering what we learnt in the classroom, you need to give your reason. So your reason is that when you square an odd number, you get an odd output, because 9 and 25 were both odd. But then when you add an odd to an odd, you always get an even number. And this is what they're looking for as your reason. Not a couple of examples like 3 squared or 5 squared, but the actual argument that when you square an odd number, it gives you an odd output, and then when you add an odd number to an odd number, you end up with an even result. Question 15. Dipen and Nisha are planning their wedding reception, and they're going to pay £40 per guest, but they're going to reduce the total by 5% if they have over 60 guests. Nisha says, I want to invite 70 guests. Dippin says, if we invite 1/5 fewer guests, we will save more than £500. Is Dippin correct? You must show you're working out. So here they're asking you to do percentages and working out lots of smaller problems. That's why it's got 6 marks, and you can't afford not to attempt the question. So let's work out Nisha's amount. She wants to invite 70 guests. So 70 times 40 is our initial problem, 70 guests at £40 per head. Well, we know how to do this quickly now. Get rid of the zeros and do 7 times 4. 7 fours are 28. And then put your zeros back. So, for Nisha, her 70 guests is £2,800. But, because she's got over 60 guests, we can reduce this by 5%. So you use your 10% rule. 10% of the amount is £280. So 5% will give us half of that. So half of 280 is £140. So we need to show that Nisha's initial amount of £2,800 will be reduced by an additional £140, giving us £2,660. Now we need to prove what Dippin says. So if we invite 1/5 fewer guests, so if we have 70 guests and divide it by 5, we end up with 14 less guests. So 70 minus 14 gives us 56 guests. Now, because he's under the 60 guest limit for our discount, the 56 needs to multiply by the £40. So if we get rid of the 0 and we just concentrate on 56 times 4, 6, 12, 18, 24, 5 fours are 20 plus the 2. So add the 0 that we started with, gives us the cost of 2240 for Dippin's idea. Now we need to subtract Nisha's amount by Dippin's amount to work out whether it's more than £500. So Nisha said 2,660, and we take away Dippin's 2240. 0 from 0 is 0, 4 from 6 is 2, 6 take away 2 is 4, and 2 take away 2 is 0. So, is Dippin correct? Don't forget to answer your question. No, they only save £420 with his idea. Question 16 is all about sequences, and it gives you patterns. So the idea with patterns is to convert the pattern into numbers to follow the sequence. So, in this instance, they're telling you that pattern 1 has 5 sticks, 2 has 9, 3 has 13. So all you need to do to fill in the missing amount is look at the term-to-term rule. So we've gone 5 to 9, we've added 4. From 9 to 13, we've added 4. So when we add 4 to 13, we end up with 17. And when we add 4 again, we end up with 21. Work out the nth term of this sequence, 5, 9, 13. So to work out the nth term of a sequence, the first thing you do is use that term-to-term rule that we've just seen, which was plus 4, and you multiply the term n. So 4n becomes our starting point. Our first term is the number 5. So when n is 1, and we swap n for 1, we end up 4 times 1, which is 4. But we need to have 5, so we need to add 1. So our nth term for the sequence 5, 9, 13 becomes 4n plus 1. It now asks which pattern is made using 53 sticks. So rather than writing them all out and spending the next 20 minutes of the exam trying to do this, we can actually do it using our nth term. So 4 n plus 1 is our sequence, and it needs to equal 53 sticks. Hopefully when you see this, you immediately think of a two-step equation. Step 1, take away 1 from both sides. So I end up with 4n equals 52. I now need to divide both sides by 4. So n is equal to, and let's do it over here as long division, 4 into 5 goes once, remainder 1, 4 goes into 12, 3 times. So n is equal to 13. So the 13th term of the sequence will use 53 sticks. Question 17 is asking us to expand and simplify an expression. The starting point is to expand the brackets by multiplying the term that is outside the brackets by each of the terms on the inside of the brackets. So here, 3 times 2x gives me 6x, plus 3 times 5, which is 15. The next thing to do is look at the next term. Now the next term this time is minus 2. So minus 2 times x is minus 2x. Minus 2 times minus 4 is positive 8. So they're trying to introduce the sign rule with negative terms. Let's tidy all this up. 6x minus 2x is 4x, and 15 plus 8 is 23. So our answer is 4x plus 23. Question 18 is asking us to solve the inequality. 5x minus 11 is greater than or equal to 29. So here, they're testing to see whether you're confused by the inequality sign. Hopefully you're not. And you can see that this is quite simply a two-step equation. Step 1 is to add 11 to both sides. It leaves you with on the left 5x, and it's greater than or equal to 40 on the right. Now we need to divide both sides by 5. That leaves x is greater than or equal to 8. On the number line, they want us to show us the solution of 3x is less than 12. Now before you do anything with the number line, you need to solve the equation for x, because it's x that we're representing on the number line. And at the moment it's being multiplied by 3. So it's a one-step equation. We need to divide both sides by 3, leaving us with x, which is our number line, is less than 4. So this is what they really want us to plot. So we know it's something to do with 4, so we colour it in. Now from our inequality, x is less than 4, so it goes off to the left. So x can be 3 or 2 or 1. Finally, we just need to check, can x be 4? Well, there's no equal sign, therefore we do not colour our circle in. So what we have on the number line is now correct. And that is the end of the questions. I hope this guide to answering November 2014 Unit 2 exam paper has been of help to you.